Have you ever wondered where the sun came from? Our story begins around 4.6 billion years ago. The protagonist of our tale, the sun, was not always the blazing orb of light we know today. It had a much humbler beginning, born from a cloud of gas and dust in the vast expanse of the cosmos. Imagine, if you will, a massive, swirling cloud of gas and dust. This cloud, or nebula, was not just any ordinary nebula. It was a special nebula, rich in elements heavier than hydrogen and helium, the raw materials necessary to build planets, asteroids, and comets. For millions of years, this cloud floated in the cold, dark space, seemingly insignificant and unremarkable. Then, something spectacular happened. The cloud began to collapse under its own gravity. The particles within the cloud started moving closer together, creating a dense core in the center. This gravitational collapse generated a tremendous amount of heat and pressure at the core, setting the stage for the birth of a star. As the cloud collapsed, it began to spin faster and faster. This spinning motion caused the cloud to flatten into a disk, much like a spinning pizza dough flattens into a pizza base. The material in the center of the disk continued to collapse under its own gravity, growing hotter and denser with each passing moment. Finally, after millions of years of collapse and compression, the conditions at the core of the disk were just right for nuclear fusion to begin. The hydrogen atoms in the core started fusing together to form helium, releasing a tremendous amount of energy in the process. This energy, in the form of light and heat, pushed back against the gravitational collapse, creating a stable, self-sustaining star. Thus, our sun was born. So, the sun, our daily source of light and energy, was born from a humble cloud of gas and dust. A cosmic ballet of forces, a dance that took millions of years, resulted in the creation of the star that makes life on our planet possible. Next time you look up at the sky, remember the incredible journey our sun has been on and marvel at the wonder of it all. Now let's move forward billions of years to the sun's current state. Our sun, the star at the center of our solar system, is currently in the prime of its stellar life, the main sequence phase. This phase is characterized by the burning of hydrogen in the sun's core, a process known as nuclear fusion. This fusion of hydrogen atoms creates helium, and in this process, a tremendous amount of energy is released. Imagine trillions upon trillions of hydrogen atoms colliding and merging every second. It's a stellar dance that happens at the very heart of our sun, under immense pressure and at temperatures reaching over 15 million degrees Celsius. This process is so intense, so powerful, that it produces the light and heat that make life possible on Earth. The energy produced in the sun's core makes a slow and challenging journey outwards, taking thousands of years to finally escape the sun's surface as light. This light then takes just over 8 minutes to travel the 93 million miles that separate Earth from the sun. Isn't it fascinating that the sunlight warming your face today actually began its journey from the sun's core thousands of years ago? Now you might be wondering, how long can this go on? How long will the sun continue to burn hydrogen and emit light and heat? Well, scientists estimate that the sun has been in the main sequence stage for about 4.5 billion years, and it's expected to stay in this phase for about another 5 billion years. That's quite a lot of time, even in astronomical terms. So, while the sun is middle-aged in stellar terms, we're lucky to be living during its stable, steady stage. This is when it's not too hot, not too cold, but just right for life as we know it to exist on Earth. The sun will continue to shine brightly, providing heat and light for billions of years to come. And that's quite a comforting thought, isn't it? The sun, our very own star, has a lot of good years left to shine. But what does the future hold for our sun? Well, it's a fascinating tale of cosmic evolution that begins billions of years from now. As our sun continues to age, it will burn through its hydrogen fuel, the primary element that fuels its nuclear fusion. This process is what provides the sun with its warmth and light, the very lifeblood of our solar system. Over time, the hydrogen in the sun's core will deplete, and helium, a byproduct of the fusion process, will accumulate. As the core contracts under gravity, the outer layers of the sun will expand, and our home star will enter a phase known as the red giant stage. In this phase, the sun will swell to an enormous size, potentially engulfing the inner planets, including our very own Earth. It's a dramatic, fiery transformation that underscores the volatile nature of our universe. But the sun's story doesn't end there. After the red giant phase, the sun will undergo another change. It will cast off its outer layers in a spectacular display, leaving behind a hot, dense core. This is the white dwarf stage. The sun, once a blazing ball of fiery energy, will have shrunk down to a fraction of its original size. A white dwarf is a hot, dense remnant of a star that once was. It's not quite dead, but it's certainly not what it used to be. It will slowly cool over billions of years, its once brilliant light fading into the cosmic background. This process from the burning of hydrogen to the cooling of a white dwarf is a journey that all medium-sized stars, like our sun, inevitably undertake. While this may seem like a somber end, it's a natural part of the life cycle of stars, and our sun is no exception. So, while our sun's future might seem a bit grim, remember that it's all part of the grand cosmic dance that is the universe. So, what have we learned about the sun? We've journeyed through its vibrant life story, starting with its birth from a humble cloud of gas and dust. From these modest beginnings, gravity pulled together these materials, igniting the creation of our sun, the heart of our solar system. Moving on to its current life, we delved into the sun as a main sequence star. It's in this stage that the sun is at its most energetic, burning hydrogen in its core and emitting the light and warmth we experience on Earth. Looking ahead, we explored the sun's future evolution into a red giant, a stage marked by expansion and cooling. Eventually, it will shed its outer layers, leaving behind a white dwarf, a dense, hot core that will slowly cool over billions of years. The sun, our closest star, has a fascinating past, present, and future. Its life cycle is a testament to the grandeur and complexity of the universe.